My name is Tai Chen. I'm a student from Troy High School. Um, I am a part of this year's RoboSub team as part of Troy NJROTC. Next year, I'll be the software commander for this team. This year, I've been part of the software team, working on designing and actually executing the software aspects of our AUV. The propulsion system of our AUV is no doubt an important aspect of our performance in this competition. The general requisites for an effective propulsion system are relatively simple: to propel the vehicle in the required directions through the use of thrusters or propellers. However, given that this competition is meant for an underwater autonomous robot, our robot needed to be able to move in the z-axis, up and down, as well as the normal x and y on land, while also maintaining high precision as human input would not be allowed to modify the robot's course while in the water. Our AUV has 6 Blue Robotics T200 thrusters, with 4 oriented horizontally, parallel to the base of the AUV, and 2 oriented vertically, perpendicular to the base of the AUV. These thrusters are bolted in permanently and thus do not swivel. We did this to reduce the mechanical complexity of the system, and since the thrusters are not facing directly forward or backward, using a specific combination of them with specific power, we can move the AOV in the direction we want without necessarily turning the entire AUV. This is especially important since some tasks require extreme precision to complete correctly, with lots of adjustments in the water. Having to turn the AUV around to make those adjustments would be a waste of time and detract from our chances of success. Confidence our team has in completing each of the respective tasks is as follows: gate 85%, buoys 90%, fin 70%, torpedo 70%, and octagon 70%. The gate and buoy tasks are relatively simpler than the other 3 tasks, as it only requires navigation and no torpedo shooting or gripper manipulation. The gate is somewhat harder since our team can acquire style points, and thus the path the AUV takes in the water will be more complex. Although the path is more complex, in terms of software, this is not especially difficult, as the path is pre-programmed. Each turn of 90 degrees will gain us points, and this can occur up to 8 times. However, there is more of a need for adjustments in this process, as the turning of the AUV might affect how it is aligned to the gate. Here, the specific thruster layout of having 2 horizontal and 4 vertical thrusters will prove effective in allowing us to gain those style points by allowing the AUV to make acrobatic movements in the water. Later, the path markers will also require precise turning of the AUV. In addition to estimating how likely we were to complete each task, we also listed them in order of priority: gate, buoy, octagon, fins, and lastly torpedoes. This ranking proved itself to be important throughout our design process, especially including the software for autonomous propulsion. When our time was stuck in the design process, that ranking helped put us back on track and allowed us to try to maximize our score at our first time competing. At home, we continued to meet every week to check on progress and make team decisions. Despite not having access to machine tools and equipment at Troy High School, our team managed to complete a working AUV. Compatibility proved to be a challenge since our team couldn't initially be sure of our system's effectiveness without testing all the components together underwater. But eventually, this situation benefited us as well. Our subteams were better able to focus on their respective tasks, and we tested the sensor and propulsion aspects of our AUV separately in the beginning. Our team accumulated hours of testing the propulsion system in the water and getting the feel of how the AUV handled underwater. Many of our team members had experience in other robotics programs that were also occurring at the same time, so many of us gained experience that way in handling the movement aspects of a robot. Since our thrusters were not custom designed, we didn't have much troubleshooting to do, and if we did, solutions were not that hard to find since other people have encountered them before we did.